So today I'm going to cover a little bit about scalability, high availability, how it goes hand in hand and why it's a bit of a balancing act, and what the impact is on your database environment. So who am I, right? First big question. Just a random fellow. Normally there was a picture here, but it's no longer here. I don't know why. I'm active 18 years in the open source world, which is, kind of long. It was before my professional career. Started as a hobbyist, of course, like a lot of people in open source. I live in Belgium, in the beautiful city of Bruges, and I'm currently a senior solution engineer within Percona. And well, I've been helping customers worldwide. And you can find me on my Twitter, which is my personal account, right? No safe harbor thingies, right? So that you can find on twitter.com. Who is Percona? Who knows Percona in this room? Okay, there's hands. People are active. Fantastic. So Percona itself is open source integrator. For the people who don't know it, we augment people's team by adding expert knowledge to their organization in regards to open source databases. We try to make sure that they use efficiently the resources of their databases in-house. And we're working on multiple technologies, right? So we work on, our core technologies that we are active on are MySQL, PostgreSQL, and MariaDB. And we're integrating with different cloud vendors and technology stacks for example, containerization and stuff like that. As organization itself, so we're not small. We worked actually with over 3,000 customers right now, and some of them are big names. I tried to grab some graphs from our website, so they're not completely reflective on who we work with, but we can not always mention who, of course. So, first question, who's using a single database in their infrastructure right now? Please, show me hands. Single database. Oh, still, people single database, great. Who is using multiple databases, like, we have Postgres, we have some Hadoop and stuff like that. What are you guys? Yeah, okay, perfect, that's great. And best question of all, who will get fired when the database is down for longer than 1 day? Fantastic, we have a winner here. So, it's a stressful, it's a stressful situation, right? So, today what I will cover is why scaling and high availability is an art form a little bit, right? So, of course, it's difficult to compare IT with art, but it's just, why we need to balance requirements and how we actually think about it from taking a step back in how we have to build our infrastructure. And also that scaling actually is not equal for each database, right? Some items, some technologies are easier to scale, some technologies are extremely crappy to scale, right? So that's something to keep in mind. Also, additionally, is a very important question, because like typical business situations, people will say, well, we need everything to be high available. And is that really the case? Is that something that you need to keep in mind of? Because is your chat application, can they, for example, be down for a short period of time if you're, for example, in the financial transaction market instead of, online messaging? So, big data pains for databases, right? Because this is a big data conference. So, biggest question is, I'm an old DBA, old school DBA from the past a little bit. Well, I don't call myself old, but the beard is getting grayer and grayer, so start feeling it. So in the past, I had situations where people were coming to me, well, we have big data, and they were talking about a couple of gigabytes. And I'm like, well, big data, fine. Terabytes, terabytes, who has a big data setup, which is 100 terabytes, 500 terabytes, something that scale, yeah. But typically it becomes very interesting the moment we become in petabytes situations, right? And scaling that is actually quite difficult, even with the different technology stacks that exist out there. And in the traditional database world, typically when we were talking about big data, it was because technologies were not really adapted for the scalability, the volume sets they were working with, the variety in data, the dynamic nature of what you're storing into it. And it's a different concept in regards to how you want to essentially scale it. Of course, with the growth of data, pressure, right? So this is I don't remember actually where I fetched that information completely, but the idea is, well, how much data is actually in the world? And we're talking now currently about zettabytes. It's not that massive if you keep track of it, but it's quite a significant amount of data, and it's growing significantly and probably will exponentially grow in the future. Also, in regards to the amount of systems and devices that are connected to the servers, this is growing exponentially. So you're actually, due to the IoT market, and it's a sexy word, but you have more and more applications, devices. You have your Hue devices, for example, in-house. You have more and more smart data devices in-house that are storing information inside potentially a database, which is then used for fetching information. So the complexity augments, the request volumes augments, the number of devices augments, and nowadays when we're talking about an initial data set where 10 years ago or 15 years ago people were talking about, well, we have a data set of 50 gigabytes, it will grow until probably 100 in 2 to 3 years. Nowadays we're talking about exponential growth typically because the amount of data they're handling is much higher. But of course, again, balancing, right? So balancing technology is an art, right? So it is finding out, balancing what you need to scale, what you need to make high available is difficult. So one of the items that I always ask is, during my conversations with customers is, well, what are you actually trying to achieve, right? So what is actually core importance of your infrastructure? So are you storing data that part of it is located, for example, in Big Data Store, and your essential information is actually a web application. Your core business is a web application where you track information and you push it, for example, to Hadoop. Or do you provide a data warehouse for treatment information, so just for scientific analysis? So they both have a different type of scalability requirements, high availability requirements. What is important for your web application is that it's, well, online, otherwise you lose customers or users. But also performance is important because after, well, there's a typical number, they say, like after 7 seconds people click away, right? So it's something important. In regards to a data warehouse, it's another type of concept, right? So what we need here is flexibility of data. We need to make sure, well, typically volumes are a bit higher. And in most cases, for example, especially with the treatment information, it contains a lot of information which maybe is not always that important, but is kept there just because you are, well, keen to have everything, right? And consistency is important because you don't want data to be invalid. So typically in those situations, it's used for long-running analysis. So those queries that are running on a data warehouse, it doesn't matter if they're running for, well, 20 minutes or 15 minutes, as long as you get their information. While if your web application is not responding within a couple of milliseconds, well, your database, at that moment it become a problem. So, but the concept of infrastructure is still scary, right? So a lot of moments that you're actually building an infrastructure which has to be capable with handling with big data. Well, you have a big data component in it, but you also have database components in it. It's very difficult. And what I've noticed in the past is that in conception, people make wrong decisions, right? So I've seen a lot of big data infrastructures on MySQL, which is not really meant for it, right? So it's not dynamic. You have problems with schema changes. But it is something that's very highly accepted, right? So it's a technology stack which is, in a way, a logical first step for a lot of developers to work with an infrastructure. NoSQL solutions, very good for dynamic data, right? So you can use, well, for example, MongoDB as a data store, document store, and it charts quite well, but it's less made than, again, for information that needs to be structured. Some people also say, like, well, relation databases are not really made for making relations, right? But that's a philosophical discussion. But essentially, technology is chosen as a conception and actually gives problems to people when they made the wrong choice. And big data solutions is one of them that is very interesting, especially when we're talking about it 5 to 10 years ago, was, well, seen as a solution that was being capable of handling large volumes of data. But what I've noticed also is that people try to fit that solution, always try to fit the solution to their workload, and that's not always the best use case. So, database characteristics, typically, yeah, it's very simple, right? RDBMS solutions are typically focused on availability of data for persistency of data. Asset compliance is typically important. Some people will argue that MySQL was not always in the past the best fit for that. And also performance for persistent queries to make sure that it's actually bleedingly fast. It's a limited data set. It's actually also in a specific structured way, and you can easily interact with it. Big data solutions are actually focused on a different sort. A lot of data points, performance, variety of data. You want to store as much input as you can. So, question about scalability, right? So, here we have a standard RDBMS system that's made scalable, right? So, who uses MySQL in this room? Oh, still a lot of fingers, nice. Everybody who knows MySQL, typical scalable solutions with MySQL in the past for high availability and, well, increased availability and scalability was typically made with a master-slave setup, right, where the slave was used for reads, and you could add slaves not until the end, but you could add slaves as you wanted, and you had read scalability. Write scalability, on the other hand, is a bit more difficult, right, because an RDBMS system is not made to be very flexible, and there's no magical unicorn solution for it. If you look at it, typically what happens the moment that people want to horizontally scale their infrastructure, they will do some functional separation of the database, or they will separate the database using sharding, right? So, and this is the example that I make where they have typically their multiple masters and separate slaves where they're doing the reporting queries on that cannot impact production. But scaling an RDBMS is very, very ineffective, in my opinion, sometimes, right? So it depends a little bit on your situation. So scaling with sharding, especially if the data fits in it, it's fine, right? If the use case is right, it's fantastic, and it will indeed increase availability, and it will do a short-term performance increase. But if you're using that, for example, to scale, as I mentioned in the beginning, where I heard a lot of people using MySQL as their initial big data platform, it doesn't scale, it will diminish in regards to performance because the overhead of having these components, even if it's a proxy, if it's an application functionality, it will actually increase overhead and performance will actually degrade. So scaling by using sharding is typically not something that happens that often in MySQL worlds, except in people which have a lot of operational knowledge with databases. But what happens often is that they simply scale up until a certain point, right? Until the Amazon account manager is very happy with having your contract, for example, right? So it depends. On the downside also, it is also a flexibility decrease because the moment that you're actually going to do performance modification, schema modifications on your infrastructure, the system will actually become less flexible because it will become more difficult to actually perform operational changes on your data schema. So big data and high availability, how does that work, right? So I said scaling is a problem with MySQL a little bit, so you can accept a little bit that high availability is a bit less of a logical step with big data solutions. So typically, you will have the possibility to actually have a standby name server, right? So which is available on the system itself, and you have multiple data nodes that control consistency in between each other. So you have a possibility to actually also have a secondary name server somewhere to use it for backups and whatever. But typically, you have a standby name server that does, well, actually nothing, right? So until that it actually happens, and it will verify. It will get some information in regards to the data nodes and the node manager. I'm not really a Hadoop specialist myself, right? MySQL guy, but that's my interpretation of it. But making big data high available can be dreadful, and we've seen that also in the past in our organization. The thing is, with the amount of volume that there's sometimes a loss of value of what's actually what you can actually fetch out of the database and how effective you are in fetching that information. So it's difficult to pinpoint which sub-select information you have to take. And it's also difficult to pinpoint, for example, what data, because in some cases, for example, that data wants to be replicated towards persistence, well, some sort of RDBMS solution or something like that. It's quite sometimes problematic, and performance can be quite dreadful the moment that you scale and scale and scale at a certain point. High availability solution is, in my opinion, still a little bit, it works well, it's based on open source technologies, but typically there's a lot of different components, and it adds complexity. It's like shared storage solutions, Zookeeper. Sometimes it's very difficult to find how the backend actually really works, right? You need to be an expert suddenly on multiple technologies instead of one. And again, it's not made for structured relational information. So the moment that somebody comes to me, oh, that's fine, I'll put it in Hadoop, I'm like, well, if you have a hammer, everything looks like a nail, right? So it's easy if you know the technology that you can potentially move towards that specific solution. So again, take a step back, right? So very important, and everything that we do quite a lot of architecture and design session with customers where we try to define their complete data center with their data structures and their data flows. And what we actually first like to understand is, well, what requirements do you have? What is required from your business perspective? How does your application interact with the database or databases? What is specifically your roadmap? How will you see it increase? How will your what are the growth expectations of the business? How about the workload? And also, something which is often forgotten, what's the deployment patterns, right? So are you guys doing continuous integration, which is another sexy word for, well, developing a lot and deploying a lot. But is that something that you guys are planning to do? At that moment, looking at different technology stacks is very important. So, important for scalability or actually for your architecture. So, I would say, first of all, if you use relational data, use something like MySQL or Postgres if you want to stay in the open source world, or Oracle DB, whatever you want to use, whatever poison you take. If you want to go towards unstructured data, or dynamic schema or something like that, I think one of the most popular ones is MongoDB. Key value store, maybe an interesting name, RocksDB, right? So I don't know if anybody uses it or knows it for key values. And for large analytical data sets, well, of course, Hadoop, for me, that's my favorite technology. It's the one that I know, well, a little bit. But again, typically it's not a single database which stores it, right? So so I would say that the moment that you're doing that investigation, you actually have to verify what the data responsibilities will be for each platform, right? So how will each platform work in regards to different technologies? For example, how will they interact? What will be the data flow? So if you are using a persistent database, RDBMS solution, for example, for your persistent data or your metadata of some infrastructure, and you need to push that towards a Hadoop cluster, well, you can use Kafka and make that flow. Also, if you're scaling technologies, it's much easier. For example, if you have a scalable infrastructure and you have a document store, you say, well, I need unstructured data and I need to scale it horizontally. Well, MongoDB, for example, has scaling built in-house. Don't use something magical with MySQL if it's, for example, for unstructured data. Read scalability, for example, in MySQL is very easy, so you can easily add slaves, but write scalability is much more difficult. So identify what needs to be write scalable, what needs to be read scalable in your infrastructure. And one big thing is don't trust your single vendor, right? So your single vendor will always say, yeah, this works out for us, right? So if you go to a single vendor, they will say, well, of course you can store documents in our document store that we developed specifically for it. While on the other hand, maybe you should use the technology which is specifically made for it. Define also your scaling needs, right? So again, not everything needs to be fantastically responsive. I think what is important is to identify what will impact your user satisfaction, right? So verify what will be your user satisfaction when something happens. It's very difficult to clarify that sometimes. And also verify what can be real-time information, how can you separate it. So maybe you understand my gist here. So scaling technologies typically is easy, right? But you need to identify what you want to scale. Well, because you cannot scale everything indefinitely. You also need to verify, for example, what needs to be having augmented volume, what needs to be, for example, stored in a big data solution. That's always, I think, important to take that step back. Again, there's no magic unicorn, right? So there's no magic unicorn in regards to scaling, I'm afraid, or in high availability. But divide and conquer, right? So divide your applications, divide what you're storing, and make sure that you actually take the different steps. And it's not easy, right? So I'm scared sometimes when I see infrastructures, but it's part of it. In my opinion, multi-technology is the answer, right? So scalability is very easy, and high availability is very easy the moment that you're using the right use case and putting the right data set in the right technology stack. So very simple, everything which is application input and processing from my perspective, which requires relational information, I store it in Postgres or in MySQL. Everything which is documents, I use MongoDB. It's made for it, right? So use it for what it's made. Don't do any weird voodoo stuff with it. Kafka, very interesting for reading and pushing information to other technology consumers, right? So it's very, very flexible. It gives you the capability to actually be flexible nowadays. 10 years ago or 15 years ago, it was a much different story where you had to write weird voodoo scripts in Perl to modify how you wanted to interact with the different data sources. Hadoop and other big data technologies, very interesting in regards to storing large data set of data. And so the moment that you actually have looked at it from a more distant perspective, you have the capability to actually make something which makes more sense, which is easier to maintain. Of course, you still need to be an expert in multiple data sets, but the moment that, well, you can always use us, of course, but you can always also have in a way, MySQL is not difficult to interact with. MongoDB neither is, right? It's just the moment that it scales further and further, it becomes more difficult. First world problems, life is hard, right? So this is not an easy choice. Scaling NoSQL is easier, right? But still has limitations, and that's probably also why the new SQL thing came up and stuff like that. And big data solutions can scale, but there's also overhead regarding to that, right? So some items, it becomes more difficult. It's also quite complex, and especially when you want to make it high available. And in my opinion, multi-technology solutions are the answer. So make sure that you choose your best technology for each use case, and then scalability will follow out of it, and also high availability will follow out of it. And fail often, right? Lose something, right? Not data, I hope, but lose maybe some motivation in regards to using MySQL or MongoDB or Hadoop. Try it, fail forward. Find the right solution is the balance, and that's what I wanted to actually say, right? And it's also a balance of technologies, and that's actually something I wanted you guys to keep track of. If you want to have a chat with us in regards to your business requirements or what your business thoughts are, we're having a drink reception at 5 p.m. So come to us, and I'll be happy to make sure that one of my colleagues has that business discussion with you guys. Thank you so much.